beta you have to calculate.
Mm-hmm.
That is what beta is called. What is beta called and what is 1 minus beta called?
Okay, don't worry, we will discuss those things. So at least, so what I was trying to say actually. So at least put some effort, right? So some effort means at least go through lectures and try to watch. If you are thinking if you want to directly attempt the question, then it is going to be trouble for you. Okay. So there is one more thing. Maybe some of you have seen in week 11 GS. So there is new type of question. How many of you have seen the week 11 grade assignments?
Yes, I have seen it is
Yeah, so
some.
there is one question which the type is bit different. Okay, so please go through those kind of questions also. So that kind of questions you may find. I mean, it basically is important for your internals. Anyway, so what I would suggest, please try to watch lectures a bit. I mean, see, if you are not getting at single time, you have to watch a second time, and still you guys have any doubts. So we are here, right? So we will, you can discuss with us. Okay. Anyway, so what I will do, I will quickly go through the some of the concepts. Maybe that will give you idea. Okay. How to apply those kind of things, and then we will try to solve some questions. Okay. All right.
Yes, sir.
Okay, so let me share my screen. Can you see my screen? This white page.
Yes, sir.
Yes, sir.
All right. So the very first thing, it's keyword here. It's called hypothesis testing. So basically, if you see, if you emphasize on the word, these two words. So what we are doing? We are doing testing of what of some hypothesis. So what is this? What is the meaning of this hypothesis actually? So basically, I can say there is a claim, okay, or assumption. Okay? So this claim or assumption we have to test. How will you do? How will you do testing and all? That is, you will based on your objective, you will select your sample, and based on your objective, you will perform some test statistic and all. Okay, so we will see basically the thing. Okay, so let me create a situation. Maybe that will give you idea. Suppose, okay, imagine imagine you are a owner of a manufacturing company. Manufacturing company. Okay. Suppose which produces medicine bottles. All right. And for example, just assume your company claims that each bottle weighs uh, exactly 200 ml on an average. Okay. So, but the suppose customers have started complaining. Okay, but the customers have started. Okay, so I'm writing a bit fast. Is it? Are you able to understand whatever the things I'm writing?
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir. So complaining about the variations in the weights. Okay. Okay. Just suppose this is the situation. Okay. You are owner of a manufacturing company which produces medicine bottles, and your company claims that each bottle weighs exactly 200 ml on average. Okay, so suppose this is the claim, this is the hypothesis, this is the basically assumption made by you. So now you are going to test this. Okay, so basically what is the question? So question is, how can you verify if your company's claim holds or not? If your company's claim holds. Okay, so that is the question. Okay, now how will you do? So the answer for this question, this is where hypothesis testing comes into the picture. Okay, so I will write. So I will write, this is where this hypothesis testing comes in. Okay, so basically what is the hypothesis? So this is the basically what is the meaning of hypothesis here? So this is one of the claim. Okay, so this claim you are going to test, you are going to verify. So there are two kind of hypothesis testing. So first one is called null hypothesis. Okay, and usually we denote it as a H naught, and another one is called alternative hypothesis. Okay, so alternative hypothesis is denoted as a H of
HA.
S subscript A. So basically this null hypothesis is what it will give you. This is something which is your claim actually. Okay, basically. So let I will write some situations. Okay, then maybe that will give you idea of it. We will try to write the uh, what to say, null hypothesis and alternative hypothesis. Okay, suppose for example, let's take a situation of medical tests. Okay, in medical test again, let me write the situation. So suppose a company wants to test if suppose there is a new drug manufactured by company. So suppose let me write, a company wants to test if a new drug is more effective than the current one or not. Okay, suppose this is the claim, or this is the assumption or hypothesis a company wants to test. So what will be by null hypothesis actually? So null hypothesis means a statement of no difference. I mean, you are assuming that is something. Okay, so what will be your null hypothesis? What will be the statement?
The current drug and the new drug have the same effectiveness.
Same effect, right? So basically I will write H naught as a, the new drug is not more effective than the existing one. Yes or no? Or you can write in both are same effectively, right? That's the same meaning. What will be alternative? So alternative will be the new drug is more effective. Are you getting how to define this things?
Sir, once could you recap the statement? Once could you read it out once?
So see, H naught is something. It's a kind of statement of or a hypothesis of no difference. Okay. So H naught. Okay. So what is the hypothesis here? Basically, what is the claim? Means a company wants to test if a new drug is more effective than the current one not. So what will be null? If you focus on the null, means there is no difference, right? So H naught I will define, the new drug is not more effective than the existing one. Basically, what I mean to say here, both are equally effective. Okay, and alternative will be the new drug is more effective. This is something you are going to test. Okay, so if I will take another example, then let me write. So suppose I'm saying a factory checks if a machine is producing item with a mean weight of let's say 100 grams. Okay. Suppose this is the situation. Okay. So what will be my null hypothesis? Mean weight is 100 gram. Yes or no?
Yes, sir.
Right? Mean weight is 100 gram. Basically, if I want to write in terms of notation, I will write mu is equal to 100. And what will be alternative? We don't know whether this is saying mean weight is more than 100 or less than 100. So what will be alternative? It will be
Mu is not equal
mu
to
is not equal to 100. That's all, right? And while here, what it will be some notation which will be greater than the existing one. Are you getting my idea?
yes, sir.
Okay, so that is the case here. Okay, so there are some basically test how will you apply and all. Okay, I mean something called when to use right tail test, left tail test, etc. Okay, so I will draw some graph and I will try to give you some idea. Okay,
Sir,
okay, so far
sir,
this.
could you explain it once again? Like, because in the first case, the null hypothesis is negation of the claim, right? Like they claim.
No, no, it's
drug is-
not negation actually. Okay, okay, this is the basically this is the kind of assumption. I mean, they want, okay, so this is the situation, right? You want to test this claim. So null hypothesis is always about null statement, actually. No difference.
Okay.
So here you can see if you focus here. So what I want to check whether the new drug is more effective than the current or not. So what will be my null hypothesis? I will assume new drug is equally effective as the existing one. What will be my alternative? The new drug is more effective. If null hypothesis is I'm rejecting, then this is going to be true. Okay, so null hypothesis is always kind of a statement which is made just under assumption that it is true. Okay. Are you getting? So null hypothesis is always a statement of no difference. You are not going to make any kind of, you can say you are not considering any biasness, something like that. This is very loose terms, but I'm trying to explain.
Okay.
Okay. So null hypothesis, you will assume, okay, this both, okay, suppose there is two teaching teaching method A, teaching method B. Okay. Suppose you want to test whether the teaching method or new teaching method has improved the average score of students in rural area schools or not. So what will be your null hypothesis? You will say, okay, both are same, suppose, and alternative will be mu A greater than mu, something like this.
Okay. So here you can say like the drug is equally effective. That will be the null hypothesis. But the alternate hypothesis can be the drug can be more effective or less effective.
Less effective, yes.
Oh, both the possibility exist.
Both the possibility, yeah.
Okay, okay.
It may be. So here it is clearly mentioned. That's why alternative is more effective.
Okay, okay. Right.
Sir, so null effective is null hypothesis is like a standard hypothesis where we are fixing one point, and alternative is like we are moving away from that point, right?
You can say yes. Basically, if I want to explain in simple terms, so again I will say null hypothesis is something a statement which is you are making with no difference. Okay. I mean, there is nothing kind of biasness is the correct word. What to say? Okay, suppose I'm saying again. Let me take another example. Suppose there is a fertilizer A, okay, which is already existing fertilizer, okay, and you want to see whether there is new fertilizer which based on that new fertilizer whether the crop yield has been increased or not. So what will be my null hypothesis, which is basically I told you, right, statement of or hypothesis of no difference. So basically that I will say fertilizer A and fertilizer B both are equally effective. And what will be the alternative? I will say, okay, fertilizer B is less effective than fertilizer A, or fertilizer A is more effective than fertilizer B, something like that. So null hypothesis is okay. Basically, it's all about, this is the hypothesis which is something you are going to test for the possible rejection, and under the assumption it is true. Okay, so okay, let me say let me write.
But if you see in every example, null hypothesis is denying na every
One
time.
second, one second, one second. See, this is the hypothesis. How will you make? Which is basically tested for possible rejection under the assumption that it is true. Okay, so this is one way to look at it. Also, see, if null hypothesis, I told you, so of no difference. So what I mean by no difference, so you will assume the sample statistics. So sample statistics mean whatever the basically your x bar is there. Okay, that doesn't differ significantly from the hypothetical parameter value. Okay, so what I mean, let me write basically. So basically, h naught I'm defining as the sample statistics. So, okay, what is the meaning of statistic here? Or sample constants I should write. Basically, statistics I mean here x bar and all I'm trying to say. Okay, this sample statistics does not differ significantly from the hypothetical parameter value. Okay, so this hypothetical parameter value is the which you are claiming. Let's say mu is equal to 100, for example. Okay, so what will be null hypothesis here? So okay, to perform hypothesis testing, what you will do, you will to test this claim, you will select some samples. Okay, so what you are going to assume basically, and how you are going to define this h naught is something. This sample statistics basically to check mu, you will go with the sample mean, yes or no?
Yes.
Right, so you are assuming this x bar will give you approximately value of this x bar will be approximately same as the mu. That's why I'm trying to say it's no difference. Okay, so you're assuming okay both are equally effective. Understood? If there are two samples, you will say okay mu1 mu of a, or let's say mu1 is same as mu2. I mean mu1 of first sample is same as the mu of the second sample. Okay, so null hypothesis basically is always all about no difference. Okay, okay, so is there some rough idea clear about hypothesis testing and all? Then we will move on the rejection region. Okay,
Sir,
yes.
sir, if null is blindly accepting,
No, it's not blindly accepting. See, you are not getting my point. So this is something basically. This is the hypothesis. This is the statement, which is you are testing for the possible rejection under the assumption that it is true. So basically, you are assuming okay, this is true. For example, okay, and according to your claim, you will test to reject or accept. Okay, so assume. So what you are assuming here, both drugs are equally effective. And what is your null hypothesis? Sorry, alternative hypothesis that new drug is more effective. So basically, what you are trying to check here, you are based on sample data and all. You will see whether this you are assuming basically under the assumption that it is true. You are assuming okay both drug are equally effective, and then you are performing for the possible rejection. It based on the sample, it may you may accept or you may reject. Okay, so basically h naught is this statement about the population parameter. Okay, so it's a hypothesis of no difference. Are you getting my point? This word hypothesis of no difference.
difference.
Okay, so this is the key thing about this null hypothesis. Okay, and the alternative is somewhat similar to your claim, and then you will select some sample and all, and then you will perform your testing procedures, and then you will I mean at the final result will be whether you have to accept or reject. Okay.
Sir, can I ask one thing?
Hmm. Hmm.
Is this can we see that this way, like when a company is claiming that our medicine is effective, and I'm challenging the statement and I'm doing the hypothesis testing, so I'm accepting the null hypothesis as there is no change, and the alternative hypothesis is the medicine is effective. Okay,
Correct.
but if they are claiming that their medicine is effective, and they do a hypothesis testing internally, so their claim is it is effective, so they will accept null hypothesis as the
So no,
effective.
no, no. Actually, yeah, your approach is somewhat clear. So see, null hypothesis is always about no difference. So if they are going to check the alternative, right, whether moved effective or not, right? Suppose I'm an analyst in that company, I will check. Okay, so whether this is true or not. Then my null, okay, null is something, one statement of no difference. Okay, hypothesis of no difference. Alternative is whether you are going to check whether, okay, this is more effective or less effective. That's all. So null hypothesis, you will assume, okay, there is no difference. I mean, at the very first step, you will assume, okay, the statement, I mean, the claim, there is no difference in the claim. Okay, basically, kind of, you can say, okay, this is unbiased statement, and then you will, based on your, you will select for, you are going to select a random sample, and based on those sample, you will perform whether that is true or not. Okay, if that is not true, this means, I mean, suppose this is null hypothesis is going to be rejected. That means this one is true. I mean, the claim, whether basically this is suspect. Okay, suppose you suspected, okay, the new drug is more effective, then this will be this alternate null hypothesis is going to reject, and your statement is true. Okay.
Okay.
Yeah. So we'll see some example. Don't worry, it will give you some idea. Okay, so let me give you some something about some right tail test and left tail test. I mean, most of the time you guys have doubt. So what is that actually? So suppose this is standard normal curve, and there is some critical value C. Okay. So what happens in case of right tail test? So this is if your value of test statistics, okay, suppose T is greater than this C, if lies here, right? So I will reject. So basically this is called alpha. Okay, I will explain you what is the alpha, and this is called rejection region. Okay, and if this is the rejection region and this part is highlighted part is alpha, then what about this part?
Accepting region.
Acceptance region, and this will be 1 minus alpha.
Yes, sir.
Okay, so in this case, suppose I have a example. Let's say you are taking the example of toss, whether a coin is unbiased or not. Okay, suppose coin is fair or not. Okay, so what will be my null hypothesis? Suppose I'm saying H naught is P is equal to 0.5. Okay, and let's say, so for this, in this case, how will I define my alternative? I will say P is greater than 0.5. Okay, so this is something called right tail test. So in this case, you can see it's on the right tail side. If value of test statistics T is greater than some critical value C, I will reject my null hypothesis. Okay, and what is the idea behind left tail test? So the graph will be, there will be a bit change in the graph. Okay, so my C will be, suppose this is left side, I'm just taking minus C, and this is Z, and this will be my alpha now, right? And this will be,
yes, sir,
1 minus alpha. So basically this is the rejection region. Okay, and how will you define your basically based on your null hypothesis and alternative hypothesis, you can identify your what to say test region, which side it's whether it's a left tail test or right tail test. So this is left tail test. Okay, so this is left tail test. Okay, so don't worry, I will take some examples. So what about both sides two tail test? So this
Sir, what actually mean by rejection region?
so rejection region means if you are computing the test statistics value, right? If that value is lying in that region, you are going to reject. Okay, you are going to reject your null hypothesis. Suppose you see something, and T you calculated, and value of T, suppose T is somewhat here, okay, then you will reject. If T is here, you are going to reject. If T is here, you are going to reject. Okay. What happens in case of two-tailed test actually? So this is Z equal to 0, and this is minus C, and this is C. So this two-tailed test, in the two-tailed test case, it may be here and it may not be here. Okay. So what about if it's about both sides? So this will be alpha by 2. Okay. This will be alpha by 2. Don't worry why I'm writing this alpha and all. I will clear in a minute. Okay. So what will be your test statistics? Tell me. Now here you will reject when T is greater than C. Here you will reject if your T is less than minus C. Yes or no? What about here?
T
Two-tailed
minus
test.
Mod of
T minus C mod
mod
must
of T
be
greater than C.
So
must
basically
be
here I will say T is greater than C or T is less than minus
Less
C.
than minus C.
So basically I can write mod of T is
Greater
greater
than
than
C.
C. Okay.
Yes, sir.
Now let's let's try to understand what is the alpha, what is this alpha actually. Okay. So alpha, so there is terms called size and power of the test. Okay. So what is this alpha? So first one is size, and this is something called level of significance also, and this is something we denote as a alpha. Okay. What is this alpha? So alpha is usually called probability of type 1 error. And what is the type 1 error? So type 1 error is defined as the probability of reject H naught when H naught is
True.
true. Okay. I will take some examples. Don't worry. What is this reject H naught and H naught is true? And what is the beta actually? So beta is defined as a probability of type 2 error. So actually there are two kinds of error, type 1 error and type 2 error. I will explain with the example, don't worry. So what is the type 2 error? Probability that accepting H naught when HA
HA
is true.
is true.
True. A next thing is called power of the test. So what is the power of the test is nothing but 1 minus beta. So if you will do 1 minus probability of accepting H naught, so it will be probability of rejecting H naught when H is true. Now, I will explain what is the two types of meaning of these two kinds of error and all. Okay, so first of all, again, I will take that example. Suppose you are a owner of a manufacturing company. Okay, then okay, so let me write that example. Change some color. Okay, now suppose I'm saying you are owner of a manufacturing company, and obviously you want to I mean you want there should be more number of sales of your products or item. Okay, suppose I'm writing um, probability of, there is a probability of I mean let's say that item has been rejected. Okay, suppose you want to test whether your I mean the product is of good quality or not. Okay, suppose I'm writing a scenario. Suppose reject an item or reject an product of good quality, and given that it is of good quality. Good quality product. Now what is this? This might happen, right? This is this probability may happen or not. This error may happen or not.
yes.
I mean, you are owner of a manufacturing company. Given that item was good quality, and even that item was rejected by the uh, customers. Yes or no? This is possible or not?
Yes.
Are you getting?
Yes.
Yes, sir.
This is the possible basically. So basically, so this is called alpha. This is alpha or not? What is
Yes.
alpha? Alpha is probability of rejecting H0, and when H0 is true. H0 was true. H0 was true means suppose the item is of good quality, right? And that item has been rejected. Are you getting my point? So this is alpha.
Yes, sir.
So alpha is probability of reject H0 given that H0 is true. So can I say this is something producer's risk? Now are you able to relate this producer's risk? It's a producer's risk. Suppose I'm a owner of a manufacturing company. This is my risk, right? Item was of good quality, but it was rejected by the customers. This is my risk, right? Good quality product has been rejected. Yes or no?
Yes, sir.
Now let's come to the second situation. Suppose I'm saying probability of accept an item or a product of good quality given that it is of bad quality. What is this?
Type 2 error.
Type
This is
2 error.
consumer's error.
This is consumer's risk, right?
Yeah.
Means I have accepted that H0, but it was of bad quality, right? This is consumer's risk or not? Yes or no?
Yes, sir.
Right? So this is, are you getting, now are you able to relate this kind of two types of error? Means you have accepted
Sir, can you
Hmm.
explain producer error again?
See, this is producer. See, this is not things we have discussed in lecture, but I'm just giving you idea, some examples. So this is producer's risk. Right? Item was of good quality, right? Suppose you are an owner of a manufacturing company. Item was of good quality, but customers have rejected. So it's your risk, right?
Yeah.
Right? This
Yeah.
kind of error may happen. Yes or no?
Yes.
Right? And what about the second case? I mean, item was of bad quality, HA, alternative, right? What is the alternative of good quality? It's bad quality. And it was accepted by the customers. So it's a consumer's risk. And this is the another error this might happen. Yes or no?
Yes.
Okay. So actually this alpha is the play a role in case of this significance level. This also called a significance level. Okay. So basically, what is the case actually? So this alpha calls sometimes it's called false positive. Okay, if you are not getting the term, don't worry. This is called false positive. And okay, so one more thing, what is the meaning of? I told you, right? So here if you see, I wrote this alpha, right? This is the alpha, this rejection region alpha. So sometimes maybe you have seen alpha we are taking 5%, 10%, yes or no? 10% or 1%. Have you seen those kind of things? Significance level is 5%. Yes or no?
Yes.
Am I audible, right?
No, sir.
Not audible?
No, you are audible. I have not seen.
Okay. So see, okay. What is the alpha 1 minus beta? I will come to that. This is probability of rejecting H0.
Rejecting while HA is true. Yes.
Right? So this is called power. I mean, this is the power. Power will be high. So power of the test. So you can see why this is power. Basically, you rejected that item and it was of bad quality. It's a good thing, right?
Yes, sir.
Okay. So sometimes the alpha is.
Sir, I have a question here. The question is why have put 1 minus beta and said that P probability of rejecting H0 by HA.
So it's a very
And-
simple thing. See, if you are
Yeah.
saying probability beta.
Yeah, I have no question about it. My question is I can also write the same thing about alpha and say 1 about 1 minus alpha.
Okay,
That
what?
was-
No. So
Then
what?
why don't we define that? Only beta we are defining, not alpha. Why?
See. What are you getting this statements here? See, 1 minus beta. What is the meaning of this 1 minus beta? You are rejecting probability of rejecting that thing, and HA was true. I mean, probability of rejecting that item, and it was of bad quality, right? So it's a good thing, right? You rejected the item of bad quality. Now,
Yes.
if you will do 1 minus alpha, what will be about 1 minus alpha? Your probability of accepting H naught,
Where
right?
H naught is true, so
Huh.
that is also a good thing. Why are we not concerned about that?
See, alpha is, first of all, you see alpha 1 minus c 1 minus alpha is good thing. You are accept. So anyway, what you are trying to see, you are normalizing to accept the H naught, right? So basically, if you see here, 1 minus alpha will give you the acceptance part, right? Okay, this is acceptance region. So if you see alpha 1 minus alpha, so anyway 1 minus alpha you are accepting H naught when H naught is true, right?
Okay,
Okay.
in this graph, where is beta here? If in this graph is the
Here
alpha.
is I didn't define beta because beta is different thing. Alpha defines the rejection region. Okay, this will help you to identify whether test statistic is more than some C or less than some C. What is the critical region when you will reject your H naught and accept your H naught? Okay, so based on this alpha, you are going to decide. Okay, that's why in this graphs I took alpha only. So basically, if I will take alpha as a 5%, let me define. So suppose I'm writing, sometimes you will see alpha we take as a 5% level of significance, right? 5% significance level. So what is the meaning of this 5% significance level? So basically, I'm trying to say there is a 5% chance of making a type 1 error. Okay, so this is one of the meaning. Okay, so now what is the
Sir,
meaning of
a
this?
small
Yes,
over
yeah.
here, can we say alpha is equal to 0.05 directly? Can we interpret?
Yeah, that's why I wrote 0.05.
Okay, yeah, yes.
Okay.
Please continue.
So what is the meaning of this 5% level of significance actually? So this means, this meaning 5 out of 100, let's say, suppose I'm uh, testing for COVID-19. Okay, so this means this meaning 5 out of 100 healthy people, okay, might uh, incorrectly test positive for COVID-19. Just assume I'm taking COVID-19. So this means, are you getting? So you are taking a significance level 5%. What is the meaning of, so this? There is a chance of making this mistake, right? So this means, what is the meaning of this 5%? This means 5 out of 100 healthy people, they might incorrectly test positive for COVID-19. Yes or no? This might happen, right? Based on some sample or not. Yes or no? Suppose you are taking alpha as a 1%, 0.01%, 0.01, or I can say 1%. So what does this mean? So this means only one person out of 100 healthy people uh, might incorrectly test positive for COVID-19. Yes or no?
Yes, sir.
Okay. So are you getting? This is something positive for COVID-19. Okay, so this is something medical studies. So this is very helpful in case of medical studies. I mean, you can relate it from here. Okay, so
here, what is the null hypothesis you are assuming here?
see, I'm not going. I'm not deciding null hypothesis here. I'm just trying to explain you what is the meaning of if I'm taking alpha as a 5%, if I'm taking alpha as a 10%, if I'm taking alpha as a 1%. Okay, so in medical cases, actually they took very less. They not usually take alpha as a 20, 10 or something. If you're taking alpha as a 20, that means you are doing something wrong, right? That is something not a good thing, right? So if you are taking, okay, suppose in medical studies, if you are taking alpha as a 1%, it's a good thing, right? You are testing for something else, and out of 100 people, healthy people, there is a very 1% chance of making the probability of type 1 error. Okay.
Okay, sir. So just one question, recap kind of. So 1 minus beta is the power of the test.
Power of the test, yes.
Not beta.
Not beta. Beta is not a power of the test. 1 minus beta is the power of test. So just try to focus on the statement. So why this is power? Power means something good thing, right? Your probability of rejecting H0 when H is true, right? So that's the, I mean, okay. You are not doing kind of ulta here, right? Okay. So HA, given that HA is true and you are rejecting H0. So that's the power of that. Okay.
So this
I
is
will.
this is the right way to this 1 minus beta, the power of the test will be the good decision making point, because probability of rejecting H0, HA is true. That's a correct statement. So
that's the correct statement. Yes. So
that's a good test.
That's a good thing. Yeah, actually, it will give you the power of that test, that particular test. Suppose beta is 0.10, you are getting 0.10 is 0.10. The power will be 0.90. Means that is the beta.
So power means the importance, the value of that.
Correct. Something, some in loose terms, you can say. So I will write.
Another question, sir. So just a question. This false positive and false negative, according to your definition, shows like this: like false comes from reject H naught, false comes from reject H naught. So P comes from H naught is true, N comes from H naught is false. Is that correct or wrong? If I interpret,
what is N you are defining?
The positive and the negative, the false positive and false negative you are saying. So first I am telling that false positive means reject H naught is true.
Correct.
So I can say false means reject. Positive means H naught is true.
Correct. Okay. You are. That's your understanding. Yeah.
Yeah. Is it the right understanding or wrong? That is
see, if you are, see, that's the way you are trying to memorize in your mind. Okay, so that's not a problem. So one way is you can make a table actually. So let me write. Suppose I'm saying this is something decision from your sample. It's already 1 hour. I am still here. I don't know whether we are able to solve the questions or not. Okay, so suppose this is decision reject H0 and this is another decision accept H0. Okay, suppose this is two possible decisions. Yes or no? And the case is suppose I am writing here H0 is let me write a bit below. Suppose this H0 is true. Okay, and then suppose here HA is true. So here HA is true, that means H0 is false. Okay. So what is the situation now? Like this. So suppose this is wrong. Okay. Means reject H0 and H0 is true. Then can I write here this is type 1 error? Yes or no?
Yes, sir.
Yes or no? Okay. What about this? HA is true and accept H0. This is
type 2 error.
Type 2 error. Okay. Now, H0 is true and accept H0. This is something correct thing, right? This is not an issue. Yes or no? HA is true and you are rejecting H0. Again, this is something okay. Correct? All right. Okay, just try to relate this part, and this part, and then this part, and then this. Okay, just think a bit. Okay, I'm just moving ahead because it's already about 1 hour. So I'm writing some example. You will tell me whether it's alpha and beta or not. Okay. So again, I will start with a very simple example. Then the probability of rejecting that item which is of good quality. Okay, what is this? Alpha or beta?
Alpha.
Alpha, right? Now, if I'm writing probability of accepting the product when it is of bad quality. What is this?
Beta.
Alpha?
Beta.
Beta, right? Correct. Very good. What about this? Suppose I'm writing probability of rejecting the product which is of bad quality. What is this?
1 minus beta.
Power. 1 minus beta.
1 minus beta. Now, let me change the situation. Suppose I'm saying probability of convicting an innocent person. Now, tell me.
False positive, right?
Right? So, what is that false positive?
Alpha.
It's alpha.
Right? What about the next thing? Suppose I'm saying convicting a guilty person. What about this?
This is also alpha.
Think of it.
1 minus alpha. 1 minus alpha.
Just think of it.
Beta. Yeah, you are but you
Power,
are
no, sir.
acquitting means like punishing, right?
Punishing, right?
Is it?
So it,
No, it means equity. Equity means living.
No,
living, right?
acute acute means छोड़ देना criminal को.
oh,
So this is beta, right?
yeah.
Yes, sir.
Okay. Now you are able to relate the things.
Yes.
Okay. All right. Okay. So let me start. Let me take. I will write the definition of p-value and then we'll start the general methodology.
Sir, a small query. Will they ask in exam such questions?
No. See,
Okay.
This
Just for understanding, right?
All story which I created, this is just for your understanding.
Okay.
Otherwise, there was no need to discuss this alpha and beta for 1 hour.
Yes. Okay, understood, sir. No, I thought such questions would be asked. No.
No.
Sometimes
So there is
we get
one.
confused.
There was one different kind of question. Maybe you can see in week 11 GA. So that those kind of questions you can try it out. Okay, that might be important for your exam point of view. Okay, so try it out, GA on your. Okay, so anyone, what is the p-value?
Alpha is the p-value.
Only alpha, or if I will write lowest significance, then that's the correct.
Yes, lowest significance.
Lowest significance level, right?
Yes.
At which
I have to reject the.
correct. I'm going to reject my H naught. So basically, let me draw the graph. Suppose okay, so this all graphs are bell-shaped curve. Okay, so I'm bad at very drawing. So suppose this is your mu, for example, just assume. Okay, so suppose this is my critical value C. Okay, this shaded region is my alpha, basically rejection region. Okay, so if value of my test statistics, let's say this is small t, if this is t is greater than C, then what I will do? I will reject my H naught or not?
Yes.
Right? I will reject my H naught at significance level alpha, right? So you got the idea of alpha, right? This alpha is 5%, means there is a 5% chance of making probability type 1 error. So what is what is the meaning of that? Means suppose you are testing, when you are doing testing, so 5% out of 100 healthy people might have the they might test the positive COVID-19, something like that. So that is the 5% meaning, or 1% meaning, you can say. So what is this lowest significance alpha? So for example, suppose even there is some value C dash, okay, and this is this part. So this is I will denote as a alpha. Let's say alpha transpose or alpha dash. So even I can reject here if my test statistics will lie here. Basically, if T is greater than C transpose, then I will say I'm going to reject my H naught at alpha dash level of significance. Okay, so basically this part is will give you the p value. So this is significance level, but it's the lowest significance level. Okay, so this will play a role while deciding for the final decision whether you are going to reject your H naught or accept your H naught. Okay, so
So
first of
what
all,
is T here?
T is the value of test statistics. Okay, you can define X bar or something like that. Okay,
It will be given on question.
uh, yes, we'll see questions. Okay, so T is the value of test statistic. As of now, just keep this word in your mind. So what is the basically
Sir,
general thing?
sir, can you please repeat the p-value again?
So p value is nothing but probability of rejecting your H naught. Okay, basically it's the lowest significance level at which you can reject your H naught. Okay, so alpha is what? Probability of rejecting H naught when H naught is 2, right? So this defined as lowest significance. Suppose alpha is here 0.5, for example. Okay, so if here alpha dash is 0.03 and your value of test statistics is lies in this shaded region, even you are going to reject. Yes or no?
So then it will be the highest significance level or the lowest?
No, it's the lowest one, right? If this region
Oh.
from here to here is 0.5%, so this will be low, right? Not high. So this is the lowest significance. Okay, so we'll solve some questions. Don't worry, that will give you more idea. So basically, what is the general methodology of doing testing this hypothesis? So suppose you have x1, x2, so on xn, which all are IID x. Okay, then you are going to define a test statistics. So that test statistic I'm writing as a T. So this T is nothing but this is function of your samples. Okay, so what is your samples here? X1, x2, xn. So what is the function of samples? X bar, because X bar you are defining 1 upon n summation of xi. Okay, you can define s square, etc. It depends on the objective of the problem, whether you have to define X bar or s square. We will see those questions, don't worry. So this is sample and this is test statistics. So what are the tests basically? So what I mean by test means when I'm going to reject my H naught. So I will reject my H naught, okay, if this is one of the case, if my value of the test statistics is greater than some critical value C. So this is right tail test. Yes or no? Another situation may be I'm going to reject my H naught if value of test statistics is less than some critical value minus C. This is left tail test, and I may reject my H naught if absolute value of test statistics is greater than C. So this is two-sided test. So what is the meaning of this? T may be greater than C or T may be less than minus C. So this is general methodology. Let me take one situation. So one situation is called test for me. Okay, you are going to test for me. Okay, what is the meaning of
Scroll
test?
down the third test.
Hmm.
So what? So please explain third test.
So this is two-sided test. When you joined the session, this is two-sided test. Value of test statistic may be less than this part or may be greater than this part. In both situations, I will reject my H naught.
Okay.
Okay. So one more thing about test for mean. Yes, Akash.
So that's in the lecture there was also sir told us that there's also a standard test in which we take two-tailed test as not equals to C. The mean is not equals to C.
I will come to that point. So
In the lecture
I'm
only.
just discussing in general till now. Okay. Let me come to that.
Okay. Yes, sir. Sorry.
So what is the test for mean? How will it start? So what will be null hypothesis actually? So null hypothesis you will define. You are going to test for mean. So this means your null hypothesis means you will assume this mu is equal to some specific value. Let's say mu naught. Okay. In the one of the example we took mu is equal to 100 gram, right? And alternative maybe mu is greater than mu naught. Okay. Now what will be your test here? Your test here will be you will reject your H naught. So this is in general if T is greater than C. Since Based on this, you can define when you will reject. Now you are going to test for mean. So what will be your test statistics? So this is same as I can write my t will be function of sample, which is I will start with the sample mean, which is I will check whether x bar is greater than c or not. Okay, so basically what does this mean? So suppose this is some mu naught and there is some value of c. We will see how to solve. And if your value based, you have collected some random sample, you took some sample mean and all, you perform procedure of hypothesis testing, and you will see if the value of x bar is will lie here, you will reject. Otherwise you will accept. That is the meaning. Okay, is the rough idea clear? Suppose there is another situation, h naught is mu is equal to mu naught and alternative is less, let's say mu is less than mu naught. Okay, now what will be your test? So test will be, you will reject your h naught if t is less than, or let's say rather than t, I will write my value of x bar is less than some c. Okay, suppose it's a two-tailed test. I mean, mu is equal to mu naught and alternative is defined as a mu is not equal to mu naught. Basically, mu may be greater than mu naught or mu may be less than mu naught. So what will be my test? So test will be, I am going to reject my h naught if absolute difference between x bar minus mu is greater than c. So basically, what is the meaning of this? So x bar may be greater than mu plus c, or x bar may be less than mu minus c. Okay, so okay, so far is it okay? Is the idea clear?
Yes, sir.
So the value of c will be given in the question or something?
As of
We
now,
have to find.
is this clear, the steps? I will come to that point. Okay, do not with hurry. If you want hurry, I will solve the question directly. Is that okay?
I'm sorry. Sir.
No, it's not about sorry. I'm just asking whether it's okay or not. So this
Yes,
C
sir,
is
it's
just one
fine.
of the critical values.
Please go like this
Okay,
only.
so C is, yeah. So
Sir,
C
I
is
want
something. Yes. हाँ.
Second वाला जिसमें we have written x bar is less than c. So इसमें तो like we are covering like even the positive ones are also.
No. Okay. So this okay. Let's say let's take minus c. If you are getting it out. So c is something you will calculate. So basically, what is the why I wrote minus c, because it's left side of this part. That's all. So that in general, what is the meaning of c? Basically, it means you are defining one critical value for left side. So basically, if I will write d, so you will say t is less than t. That's all.
This makes sense. Okay, thank you.
Okay, understood, right? That's all. That is. Okay, all right, great. So I will write in general steps, then I will move on the question part. Okay, we will see. Okay, so now who asked about the C? Don't worry, I'm not going to do anything. The C part, you had a doubt, right? C will be given or not, something like that.
Yes, sir. Yes, sir.
Okay. So now you will see. You will check how will you calculate your C. Basically, see, if you are collecting a random sample to test the claim, x bar you can calculate from your sample itself. Yes or no? Suppose your samples is something 1, 2, 3, 4, 5. What will be x bar? X bar will be 3, right? X bar you can calculate from the sample. Now C is going to be something you have to calculate. Sometimes it will be given in the question, then you have to take decision directly, or it may not be given in the question. Okay, it depends. So now let me write actually in general steps. Okay, so in general steps, basically, what is the key steps you have to perform whenever you are doing hypothesis testing? So first of all, I will do test for mean. Okay, so test for mean I will write for this. So test for mean, actually in this case, suppose sigma square is known. Okay, now what this mean and all, basically what is the meaning of sigma square known? Suppose I'm saying x1, x2, so on. This is xn, this is IID x, and this x is having some mean mu and variance. No, I'm not defining normal. Just assume it's mean mu and variance sigma square. Okay, and this sigma square is known. Okay, means it's given that variance of this x, this population distribution is given to you, but you don't know mu. You are going to test for mean, and you have some claim about mu, and based on the collected sample you will test for that mu whether the claim about mu is true or not. So that's the hypothesis testing. Okay, so what are the key steps actually in case of this part? So suppose as of now, let me take h naught is, I'm saying mu is equal to some specific value, let's say mu naught. Okay, and I'm starting with the alternative, let's say mu is greater than mu naught. Okay, now tell me what will be the my test. My test will be, I will reject my h naught. When you will reject by saying the alternative, can you tell me when I will reject my h naught?
When x
When
bar
Is
is
greater than
When x bar is greater than c.
very good. Now this is the my test. Now how to start? Okay, so the first step. Okay, I mean, anyway, so this is the first step. You to define a hypothesis, and this is actually second step. So step 3, let's write step 3. So you will start with the alpha. Basically alpha will be given to you in the question. I mean, sometimes beta will be given to you, so accordingly you have to start. Most of the time alpha will be given to you. Basically it will be mentioned, this is the significance level. Okay, this is the alpha. So alpha is basically probability of, what is the alpha? Rejecting h naught when h,
While h naught is true.
right? Now suppose, just assume alpha is 5%. I'm just taking alpha is 0.05, just hypothetically. Now when you will reject your h naught?
When x bar is greater than c.
When x bar is greater than c. Very good. And what is the h naught? H naught is mu is equal to mu naught.
Yes, sir.
Okay, so far so good.
Sir,
Now
that
what is
rejection
the,
part, excuse me, the rejecting h naught if x bar is greater than c, it is, you have taken it hypothetically or
no, it's based on your alternative hypothesis.
okay, okay. Sir, but in questions
Basically,
it's not directly
basically
that.
suppose this is mu naught. Okay, okay, I'm saying, I'm assuming mu should be greater than mu naught, so greater part should be here.
Yes, sir.
Okay, so you are going to find a critical value c for which your x bar will be greater than c. Then you will reject, otherwise you will accept. Yes or no?
Okay, sir.
Okay. Now basically, okay, so what is the next step? You to convert in standard form. Okay, so by the central limit theorem, if n is large, okay, so this x bar will be x. What will the distribution of x bar? Tell me.
Normal.
Normal 0, 1, right?
Yes.
Okay. So one more thing I would like to write here. If x1, x2, so on, xn, this all are IIDx. Okay. And suppose with the let's say normal, just assume it's a normal, it's a mu comma sigma square. Okay, what is the distribution of x bar? Okay, forget about normal, let's say it's let's say
Normal
with
will be
mu
normal.
and sigma square. What is the distribution of x bar?
Will be
I
mu
will say
comma
normal
normal distribution. Yeah, with
Mu
the mu
comma
comma
sigma
sigma square.
square.
sigma square
Sigma
by
square
n,
by
right?
n.
Sigma square by root.
So basically under central limit
n.
theorem, if n is large, this is something I can say. Yes or no?
Yes, sir.
Right?
Sir, I
Central limit
cannot
theorem.
follow you. So I cannot follow you. From here with IID mu and sigma square, then yeah, then it should follow n mu sigma square. Why sigma square by n? What was the central limit theorem that would know?
Okay, I don't think you should ask what is the central limit theorem.
Sorry, just a second. Please tell me.
See, this is something that is your job to revise. Okay, so suppose, see, x bar is something x1 plus x2 plus xn divided by n, right? Okay, this is x bar. Yes or no? If I
Yes.
am to find expectation of x bar, then what will be the numerator part? Expectation of x1 plus expectation of x2 plus so on, expectation of xn divided by n.
Yes.
So this will be n mu divided by n, and will get cancelled out. So mu only.
Okay, and same for the variance I have
Same
got.
for the variant. So let's say this is normal mu comma sigma square. Okay, let's say normal mu comma sigma square. Even by the central limit theorem, it will follow normal, but just assume it's a normal mu comma sigma square. Okay. So what is the key thing actually? You have to convert anyway. So we are we have assumed normal. So what is the next step? I have to convert into standard normal form. So what is the steps to convert in standardized form? We have to subtract the expectation and we have to divide by the standard deviation, right?
X minus mu by sigma.
So basically not mu by sigma. See here, x bar, I will do minus expectation of x bar divide by standard deviation of x bar. Do you agree with me?
Yeah.
Yes.
Greater than, since we have to do on both sides, c minus expectation of x bar divided by standard deviation of x bar. Yes or no? And given that mu is equal to some value of mu naught, just leave like that. Okay, so far so good. Now what is this? First of all, okay, let me write. What is the x bar minus? What is the expectation of x bar? Mu itself. What is the standard deviation of x bar?
Sigma by under root n.
This is greater than c minus mu divided by sigma by root n. Given that mu is equal to mu naught. Now what is this? What is this? This is what?
Z.
This is z itself, right? Because we have converted in another form, right? So I will write g greater than c minus, let's substitute the one specific value of the mu, which is, let's say, mu naught divided by sigma by root n. Yes or no? And this is something we took. Okay, let's take alpha itself, because it's, we are talking in general, so let's go in general itself. Suppose this is alpha. Now some fz value will be given to you. So to convert in fz, what will the case? Can I write this as a alpha equal to 1 minus probability z lesser equal to c minus mu naught divided by sigma by root n?
Sir, please explain the last line previous. Previous.
This is
yes.
This is z greater than part, right?
Yes.
To convert
I understand this part, c minus mu naught.
I just substituted the value of mu here. This is mu and there was one value of mu. Mu is mu naught.
Yes.
Okay? Now here I can write alpha is equal to 1 minus fz of c minus mu naught divided by sigma by root n. Yes or no? Everyone is getting this part?
Yes, sir.
Yes, sir.
From here, what else can I write? Can I write fz of c minus mu naught divided by sigma by root n is equal to 1 minus alpha? Yes or no? Now from here, what else? Can I write c minus mu naught divided by sigma by root n is equal to fz inverse of 1 minus alpha? This is something, it will be given to you from the table. Now from here, I can calculate the value of c or not. So can I write c minus mu naught equal to sigma by root n fz inverse of 1 minus alpha? Yes or no?
Yes,
just
sir.
mathematics. So c will be mu naught plus sigma by root n fz inverse of 1 minus alpha. So this is something, value of c you can calculate. So mu naught will be given to you from the hypothesis. Sigma will be known to you. Sometimes sigma is unknown, so that is the difference situation. That is t statistics. We will see later. And n is the sample size, and alpha will be given to you whether it's 5% or not. So now you got the value of c. So whatever your test, you are going to reject h naught if x bar is greater than c. So x bar you can calculate from the sample. So what you will check, you will calculate the value of c from here, and you will see whether if x bar is greater than c, then you will reject your h naught. Otherwise, you will accept.
Sir, and here nu naught is the claimed hypothesis, like the claimed whatever parameter we are using.
This is mu naught. Suppose mu is equal to 100, so it will be 100. Okay. So this is case.
One thing, if the value of c would change according to the problem, like if this was a right side right tail test, if it was a left tail test or a two tail
Correct.
test,
So here it will be less than sign, less than sign, less than sign, less than sign. Then in that case, there is no need to do 1 minus this object because this is less than sign. You can directly write that part. Okay.
And two tail would be half. There will be some half also somewhere.
No.
We'll add it like.
Okay. So don't go there. If it's two tails, so here it will be mod sign, mod of this. Okay.
Oh. That is
Okay. So basically, what you have to do, you have to substitute the reject H naught part here. If it's one tail, X bar greater than C, X bar less than C. If it's two tail, so you substitute absolute value of X bar minus mu is greater than C. Okay. Okay. So one more thing, everyone is having pen and paper right now.
Yes, sir.
No, sir.
Yes, sir. Yes.
Okay. So if not, please take it. We will try to solve some questions. Okay. So these are the key steps to do test for mean. Okay, so this is called jet test. Because why jet test? We are using jet test if sigma square, that is population variance, is known. If it's unknown, that is t test. We will see in the, that is I think in week 12. So don't worry. But to perform jet test, to test for mean, it's a jet test you use.
This is the
sigma
jet
square.
test that you have.
Yeah, this is jet test. This is jet test. That's why I wrote
jet value here.
Yes, this is jet test actually. Jet test for me.
But
So that's why I wrote
is
abjet.
Z test and CLT the same? Is Z test and CLT are the same?
CLT is one of the concept, right? So that concept says x1, x2, xn is something is from suppose any distribution, right? Independent or IID.
Yep.
That distribution of summation of xi, distribution of x bar will be normal. Okay.
Yes.
Using that concept, we are performing hypothesis test.
Okay.
So everyone, you are aware about this peer deck, right? So just open your browser in your phone or laptop, desktop, whatever you have. Write down joinpd.com and then, sorry, write joinpd.com and then it will ask a code which is SNSBTN. And let me know if you are facing any difficulty to join the. Okay, is there any session from 8 p.m.?
No, sir.
No? Oh, all right.
No, sir.
Okay, then. Okay, so 15 of you have joined. Others, please join it fast so that we can start. Okay, so this is the one situation. Question number 1. So suppose x follows normal mu comma 4. This is the population information. Here you can see 4 is given to us, right? It's known to us. So for n is equal to 100 IID samples of x, the observed sample mean is 11.8. So what is this 11.8?
X bar.
X bar, very good. What conclusion would a jet test reach if null hypothesis assumes mu is equal to 10 against alternatives mu is not equal to 10? So if mu is not equal to 10, tell me what will be your, this is two tail test, one tail test is what? What is this?
Two tail test.
Two tail test. What will, when you will reject your H naught?
Both alpha by 2 this side and that side.
Forget about alpha. How will you write your test? Just I wrote here like this, right? I'm going to reject my H naught if X bar is greater than C. Now what will be your statement there? When you will reject your H
bar
naught?
is less
Such
than C
statement
or
will
X
be
bar is
rejected
greater than
not
C.
if x bar minus mu is greater than c, or x bar is less than mu minus c.
This part actually, this case. Okay.
Yes.
Yes or no?
Yes.
Yes, sir.
So basically, what is the case? What is the meaning of, suppose this is, and just assume this is your mu and somewhat c is here and minus c is here. Okay. So this is this part, this part. So when you will reject your alpha, basically where the difference is x bar minus mu is greater than c, or x bar is greater than mu plus c. Basically, this will be mu plus c. Okay.
So,
And x
sir,
bar is less than mu minus c. Okay.
sir, I have a doubt here. Like in the other test, like we will be having just X bar is less than minus C or X bar greater than C, right? Why in particular for this one we'll be considering X bar minus mu with C?
Basically, see, in two-sided test, you want to check whether see, if you have single test, right? So single test means what, you'll say, oh, this is greater than my critical value or not. Okay.
Yeah.
Basically, that will give you, anyway, that will give you this okay, this is your mu only, right?
Yeah.
Okay. I mean, you want to try to say x bar is mu plus c or x bar is less than mu minus c, something like that.
Yeah. Here also we can compare X bar minus mu is greater than C. Right?
Basically, what we are trying to say, check in both sided whether the absolute difference of those two is greater than some critical value or not. Okay. As of now, just keep this in mind. Okay. I will.
Okay.
Yeah.
Okay.
So basically, in case of two-sided test, we will check the absolute difference of x bar minus mu is greater than c. So just solve this question. I will explain those part. Okay. So basically, what? Okay. So what will we? How will you start? According to this, alpha is here. It will be absolute difference of x bar minus mu greater than c, right? Yes or no?
Yes, sir.
Yes. Yeah. Just start like this. I'm giving you some 2 to 3 minutes, and please do let me know if you need extra time limit for the question. Okay. Any one of you need extra time limit?
Yes, sir. Maybe another one more minute.
Oh, all right.
Sir, can you share the code again, sir?
So code is, you can see on this top right side corner, SNSBTN.
Thank you, sir.
Okay, any one of you need extra time limit, or should we proceed? Yes.
So I can't understand the methodology properly to pose this question.
Okay, no worries. We'll try this one. Okay. Yeah, so I think someone was asking that question. Let me give you that. Actually, it's all about this mu naught actually, because I'm going to use the hypothetical value of mu naught. Okay, this will be mu naught. Understood? So you are interested to know how far it is from that value. Okay. Here, sometimes we loosely define whether we can see this is mu naught plus c, but sometimes we simply write x bar is greater than c. That's one of the constant. Okay. Okay, so how? Okay, what is the question? So first of all, let me see the responses from your end. 2525 Okay. First of all, which test statistics you have used here? X bar. Sample mean, right? Test statistic uses sample mean. So 2 is correct. Then 5, two-sided test is used, right? Okay. So let me start. So first question, so number 1. So what is the given part? So given part is X is normal distributed from mu comma 4. We don't know mu. We have to, there is some hypothesis about mu. So x1, x2, x100 is collected from this x. So this is IID x. Okay. What is the x bar? X bar is 11.8.
11.8.
Right. And what is the alpha? 0.05. We have to take. Right. And what is the h naught? Mu is equal to 10. Right. And HA is mu is not equal to 10.
10.
So basically, what is the my test will be here? So my test will be, I am going to reject my H naught if absolute difference is x bar minus mu. Basically, I will take as a 10. Let me write in general the x bar minus mu greater than some c. Okay. Okay. Tell me if given x is normal mu comma 4, then what will be the distribution of x bar here? It will be normal. What are the parameters?
Normal
It is mu
comma
0,1.
4 by
100.
100. Right? Sigma square by n, right? Now, so I told you we have to start with alpha. So what is the alpha? Is probability of reject H naught. When
So
H
before,
naught.
excuse me, sir. Sir, is this the general case that we have to take x minus nu as greater than c always?
It's a two-sided test.
So we have to do this always, right, for a two-sided test.
Yes.
Okay.
So basically, it's in general we have to take absolute value of, I think you missed in the beginning. We have to take absolute value of t is greater than some c. Okay. T is the test statistic. If you are doing test for mean, then it will be x bar, and if you doing for variance, then it will be s square. So variance and all we will see it later. Okay. So T is the test.
It's for the z test only.
Yes,
This
it's
case.
for G test. Yeah. So
I'm
G test,
getting confused
because
with all the types of tests.
when variance is known to us to test for the mean, G test is applicable. Okay.
Okay.
Now, so here when we are rejecting H naught, let's focus. So X bar minus mu naught. Basically, here you have to write mu naught. So mu naught greater than C, and what is the H naught? H naught is mu is equal to 10. So far, so good. Yes or no?
Yes, sir.
Yes. Okay. So, uh, okay. All right. So what will be the case here if let's say mu? So can I write this absolute value of X bar minus 10 greater than C? Yes or no?
Yes, sir.
I just substituted the value of mu, right? What else I can write? So X bar is follows normal mu comma sigma square. Basically, it's sigma square by n is what? 4 by n. 4 by 100. Yes. I think you will get confused
Yes,
here. Okay, so to convert this into standard normal form, what I have to do? I have to do X bar minus expectation of X bar, that is X bar minus mu, divided by 2 by 10 will follow normal 0 comma 1. Yes or no?
Yes.
Right.
Yes, sir.
So it's, you can see here X bar mu is already subtracted. Then what I have to do? I have to just divide by 2 by 10. Yes or no?
Yeah.
Are you getting? So this is mu is equal to 10. And what is this? This will be what? G
Yes.
greater than, can I write? This will be 2 by 10, 1 by 5, 5 times C. Right? There is no role of mu, I think now. So can I write here this one as a G greater than 5C or G less than minus 5C? Would you agree with me? Okay. If this is the case, can I write probability G greater than 5C plus probability G less than minus 5C? Yes or no?
Yeah.
No, there is.
Sir, one question. How did I get 5 here? I got 1/5 here, 2 by 10. Then I cross
2 by 10 is in the denominator.
Oh, sorry.
So basically, I will draw the graph. Okay, suppose standard normal graph. Suppose this is Z, or since it's standard normal graph, so this is 0. Okay, if there is minus A and A, by the symmetricity property of standard normal curve, we know probability that Z less than minus A. This is same as probability Z greater than A. Yes or no?
Yes.
If this is the case, can I write this as a probability Z less than minus 5C, this part, plus probability Z is less than minus 5C, yes or no, this part?
Yeah.
Right. Now, this is the case. So, can I write 2 times of probability Z less than minus 5C? And alpha is 0.05. So, this will be 0.05 divided by 2. That means 0.025 equal to probability Z less than minus 5C. Would you agree with me? Yes or no?
Yeah.
Yes, sir.
So what is this? Can I write F? Okay, probability G. Just let's change the side. It will be 0.025. So can I? So this is already in less or equal to sign. So can I write Fz of minus 5C equal to 0.025?
Yes.
In it out. Now in the question itself, it is given that Fz of minus 1.96, Fz of minus 1.96 is 0.025. So what will the value of Fz inverse 0.025 here? Minus 1.96. So basically, from here, what else can I interpret? Can you tell me? Can you see? So minus 5C, can I write as same as minus 1.96? Okay, let me write one more step. Can I write here minus 5C equal to Fz inverse of 0.025? Yes or no? Then from here, can I write minus 5c equal to minus 1.96? So what is the value of c here? Can you calculate? 1.96 divided by 5? Anyone? What is the value of this?
0.39.
0.39. Okay. So this is the C. And we saw our test. I'm going to reject my H naught if absolute difference between x bar minus mu is basically mu naught is greater than some C. Now, what is the x bar? X bar is 11.8. What is the mu naught? Is 10. We have to check. So this will be 1.8. Yes or no? So this 1.8 is greater than 0.39 or not? Yes, no?
Yes, sir.
Yes, sir.
This means what?
We'll reject
We are going to reject.
H naught.
Okay. This is rejecting H naught. Okay. Is this clear now?
Can you scroll up a bit, please? One glance I want to do.
A bit more, sir.
Yeah, can you scroll up a bit?
When we put the alpha 0.05 by ourselves, there is no information given in the question for it.
No, it's given, right? Oh, so it's given in the option. It's fine.
So, but it's that question, right? We have to make it ourselves.
Don't worry about it in exam. Exam it will be clearly mentioned.
Okay.
So from the options also you can identify. You have to check for 5% and 10%, right?
Okay, we have to take the alpha value. Okay.
Yeah. Okay.
So would you scroll a bit up, more up?
Till where? I think is there any steps or something?
Above that a bit. Yes. Yes, this one.
So based on the alpha, we have calculated C, and then we have
We have to start with the alpha, right? We know this is the critical region, right? We know the critical region, but we don't know that threshold value, that C, right? Based on the critical value, I'm going to find critical region. I'm going to find that C, right? Once I got the C, I have some information about my sample. I will decide whether this is greater or less, and whatever. Then my final decision. Okay.
Okay.
Yeah. Okay, so this next two pages are solution of this question actually. Okay, so there is another question. It is claimed that the lifetimes of light bulbs are normally distributed with mean of 100 hours and standard deviation of 2 hours. Okay, we wish to test hypothesis that mu is equal to 100 and alternative is mu is not equal to 100. All right, with a sample of size 9. Okay, so find the significance level if the acceptance region is this. So what will be the rejection region?
Rejection region. So 1 minus the acceptance region.
Just draw the graph, you will get idea. If this is the acceptance region, you are accepting if x bar is between this, so x bar is greater than some part or x bar is less than, then you will reject, yes or no? First of all, this is two-tailed test or one tail test?
Two-tailed test.
Two-tailed test.
Okay, so I'm giving you some 3 to 4 minutes. Just try it out. If you're not, we will discuss that now. But try with your honesty, okay? Okay, do you need extra time limit?
One more
Yes,
minute.
sir. 1 more minute.
Oh. So here you have to calculate alpha itself, right? Let me see. There is only 2 responses. Do you need extra time limit or should I proceed?
Yeah, I think you can.
2 minutes more, sir.
2 more minutes. Okay, I have 3. Okay, let me give you 1 more minute, and then I will extend for 1 minute. Okay, so let me extend for 1 more minute, then I will discuss the question. So sometimes see some changes will be given to you, means, but concepts are same actually. You to the procedure, the steps, the things which you have to follow, that should be the same. Okay, let me see the.
So alpha is coming out to be 0.024.
Yeah, it's fine. I don't know actually. I have to solve. I don't know the exact answer. We'll solve that part. Okay. So question number 2, part A says. So what is the information? Is saying X is defined as a random variable, which is, let's say, lifetime of light bulbs. What is this? This is normal. What is the parameters? 100,
4.
2.
4.
2 is the standard deviation.
Yes.
Okay. So first of all, n is 9 given to us, right? 9 samples they took. Basically, what they did, x1, x2, so on, xn. It's from IID x. And what is the h naught? Is mu is equal to 100, and ha is
Mu
mu is
unequal 100.
unequal to 100, right? Now, so one more. Okay, what about distribution of x bar? It will be normal. 100, 4 by 9. Yes or no?
Yes.
So acceptance region is given to you. Okay, so acceptance region is given to us a 98.5. Okay, so 98.5 is lesser equal to x bar is equal to 101.5. Okay, This is the acceptance region. What will be rejection region? First of all, this is the two-tailed test. So in case of two-tailed test, what is the how will you reject? I will reject my H naught if
modulus of x bar minus mu is
basically mu or mu naught, you can say greater than c, right? So basically I'm saying x bar is greater than mu naught plus c, or x bar is less than mu naught minus c. Yes or no? All right, yes or no? This is the case, right? So I think someone was asking, I don't know his name, what is this mu naught c and mu, why not in case of single test mu is mentioned there. Actually that's a mu naught plus c. Okay, you can define this whole thing as a c. Okay, that's not a problem. Okay, that's right. Basically you want to check whether how far is from the original mean, that's all. So what is the alpha? Alpha says probability of rejecting H naught when H naught is true, right? When I will reject my H naught, this is acceptance region. Then what will be the rejection region? If X bar is greater than 101.5 or X bar is less than 98.5, only then I will reject. Otherwise, if it's in between, I am going to accept. Yes or no?
Yes.
Right. This is acceptance region. What will be the rejection region? When it's less than this part or greater than this part. Is this clear? Now to make it, what is my next step? I have to convert in standard normal form. To convert in standard normal form, I have to subtract the mean and I have to divide by standard deviation. Yes or no? So what will be the case? Can I, what X bar, what is the mean? 100?
100.
Yes or no? And divide by
2 by 10.
2 by 3, correct? Greater than 101.5 minus 100 divided by 2 by 3. Yes or no?
Yes, sir.
Yes,
sir.
Yeah. Okay. And this will be X bar minus, basically mu, I'm just substituting the value of mu directly. Is this okay? Divided by 2 by 3 less than 98.5 minus 100 divided by 2 by 3. So far so good? Any doubt in the steps?
No.
So this will be probability. What is this? Can I write G directly?
Yes, sir.
Greater than, what is the value of this? 100.5, I think 1.5 divided by 2 by 3?
It's 2.25.
2.25, okay. So Z is greater than 2.25, or what is this? Again, Z less or equal to minus 2.25. Right? If this is the case, can I write again same mathematics? So probability Z is greater than 2.25. So I can write plus probability Z less than minus 2.25. So by using the symmetricity property, I can write this as a probability Z less than minus 2.25. Yes or no? Plus probability Z less than minus 2.25. Is this clear? This step is okay to all of you?
Yes, sir.
And this will be 2 times of probability Z less than minus 2.25, and it will be 2 times of FZ of minus 2.25. So I think this value is given in the question, right? Okay, 0.012. So 2 times of 0.012 will be 0.024. So alpha is the 0.022. Clear? Yes, no?
Yes.
Okay. So yeah, this calculation is there. Okay, so there is a second part of this question. So what is the second part? In all the information is same. What you have to calculate basically, I have to calculate the power of the test. And what is the meaning of? I think I'm getting answers. How you are doing? Are you using ChatGPT?
So power test means 1 minus beta.
Yeah, that's what. So what is the meaning of this statement? So it's a 1 minus beta. We have to calculate, right? So in question number 2b, we have to calculate 1 minus beta. That is probability of reject H naught when HA is true, right? What
Yes,
I'm
sir.
trying to say, I have to calculate, I have to solve probability of reject H naught. When you have to reject, what is the meaning of this HA is true? So basically it says alternative that the true mean life is 103. So what is the alternative? In the question it says mu is not equal to 100, but we have to calculate what is the power of the test if mu is 103, right? So it will be mu is equal to 103. Sometimes people make mistake, they directly took mu is equal to 100. No, so that is H naught. Okay. Okay, so please be careful in those situations. Okay, now you have to calculate 1 minus beta. So all the steps are same. Instead of 100, you have to subtract 103. That's all. Okay, so just solve it. I'm going to give you 3 minutes, and do let me know whether if you need extra time. Okay.
So the condition for acceptance would be the same as before. 98.5 between the X bar is between 98.25 and 101.5.
So everyone is trying, right? I'm assuming you are not trying. You can let me know. Accordingly, we will proceed with the session. Okay, so anyone, do you need extra time limit?
Yes, sir.
How much? One, three.
Sir, two.
Okay, let me. I don't have option of two, but I will increase one more. Okay, let me case for 1 volt. Okay, so you are getting idea, right? How to solve the questions. So still you are facing difficulty. Okay, so silence. Always, I'm assuming you are getting everything.
Sir, here we have to subtract with 103.
Yes.
Yes. So there we are getting some problems, sir, because
No. So it's clearly see.
no, no, so it's clearly say,
How 1 minus beta is new question. So 1 minus beta is defined as a probability that rejecting H naught when HA is true, right? So if you are writing HA is true, so HA is defined as a mu is not equal to 100, correct? I don't think any answer is correct because power of the test shouldn't be less. See, 1 minus beta H is true, and in the question, what is H naught? Mu is equal to 100, and HA is mu is not equal to 100, right? But we cannot put mu is not equal to 100, right? But how will you solve the question? For the sake of simplicity, what says in the question? It says I have to find the power of the test. See, mu is not equal to 100, but there is one specific value of mu is given to us. We have to find the power of the test when mu is equal to 103, which is not equal to 100. This 103 is not equal to 100, right? Correct. So for this specific value of mu, we have to calculate the power of the test. Okay. It says reject H naught when HA is true. And when you will reject your H naught, we saw X bar is greater than 101.5 or X bar is less than 98.5. Yes or no? X bar is greater than 101.5 or X bar is less than 98.5, given that mu is equal to 103.
Yes, sir.
And what is the next step? I have to subtract this mu and divide by standard deviation. So
S
this
bar minus 103
divide by
2 by 3
2 by 3. Very good. Greater
greater
than
than
101.5.
101.5 minus 103 by 2 by 3
Very good. Or X bar minus
minus
103
103 by
divided by
2 by 3
2 by 3
less than 98.5 minus 103 by 2 by 3.
Very good. So what is this? Now this will be
Z.
Z and this will be
Z.
Okay, so
Sir, we are
basically,
not given the FZ values here, right?
sorry,
We are not given the FZ values
this is
here.
given, right? I mean, this same information, this FZ minus 2.25.
Sir, I am getting P of Z less than minus 0.6.75 plus P of
Don't
Z
worry.
less. Yeah.
Don't worry, I will come to that one. I think you
Okay.
are missing a very minor thing, but it will be clear. Don't worry.
Okay.
Probably Z greater than what is the value of this?
Minus 2.25.
Okay, minus 2.25. Or G less than what about this?
Minus 6.75.
Very good. So what else can I write? Probability Z greater than minus 2.25 plus probability Z less than minus 6.75.
Yes, sir.
Since this is greater than, to calculate the FZ value, I can write 1 minus probability Z less than minus 2.25 or not.
Yes, sir.
All right.
Yeah, I did till this part. After that, I
No worries, it will be clear. So FZ of minus 2.25 plus FZ of minus 6.
Minus 6.75.
Tell me, this Z is nothing but standard normal variable. Yes or no?
yes.
This is mean 0. So if you see from minus 3 to 3, what is the probability? 3
Very,
standard deviation.
very less, next to zero.
0.997, something like this, right?
Yes, around 97%.
97%.
99%. Yes,
Right?
97%.
This is, or not? I think what this term?
Yes. Yes.
Yeah, this is three standard deviation rule, right? Now, if you see for minus 6, so this is somewhat here, right? Very close to 0. Yes or no?
Yes. Negligible. Yeah.
Negligible.
0. Mhm.
So this will be approximately 1 minus, and object of minus 2.25 is 0.012 plus 0. So basically it will be 0.012. 987 if I'm not wrong. Is this clear now?
Yes, yes.
This
Thank
will
you.
be
So value of fz of minus 6.75 is not 0, but so close, very close to
you
0.
can say approx to 0. You can take
Yes.
solve the questions. You can write it 0.
Sir, if we don't have the values, like for some minor values, we can calculate 0.
Some minor volume is what?
Like here minus 6.75.
In this case, it will be 0. If fz of minus 10, it will be 0. But for other situation, values will be given to.
Okay.
Sometimes, suppose if I am writing fz of 0.5, tell me. Oh, sorry, not 0.5. If I am saying fz of 0, what will be value of this?
So
I think
0.5.
Basically, this way z probability z is less or equal to 0. That is
Yes.
0.5 because of symmetricity.
Half.
This is
It
half
means
and
half.
this is half, right? So
Yes.
this kind of things you can keep in your mind. Okay. Okay, so let's move to the next question. So next question is something a bit different to identify. So a commonly prescribed drug for relieving nervous tension is believed to be only 40% effective. Okay, and to determine if a new drug is superior in providing relief, okay, suppose that 100 people who are suffering with nervous tension are chosen at random and inoculated. If more than 50 of them are found to be relieved, we reject the null hypothesis that P is equal to 0.4. Okay, if P is equal to 0.4, and what is the alternative? What is the alternative?
P is equal to 0.6.
It would not be equals to
No,
P
can you read the
0.4.
question again? What is the test? If P is equal to 0.4, what is the alternative? What they want to test?
The drug is superior to the
Superior,
one
that
currently
means
in use.
P is
Greater
Less
than
than
0.4.
0. Okay,
greater
greater.
Greater than 0.4, right? Okay. Null hypothesis is 0.4 and they want to test for superior part, so P is greater than 0.4. I mean, P means I'm talking about probability. I mean, that proportion actually. All right. Now, what is the sample size? 100?
100.
Now, another thing. What is this? What is the role of 50 here?
That is C value.
That is C value, correct? Because it's clearly mentioned if more than 50 of them are found to be relieved, we are reject H0. And usually we define our test statistics. This is question number 3. Okay. So question number 3, what is the null hypothesis? This proportion is 0.4 and alternative is P is greater than 0.4. Yes or no?
Yes.
Okay. So what will be my test statistic? Test statistic. Okay, what is the persons? It's x1, x2. They are doing for 100 people, right? What will be my test statistic? I'm interested summation of all these xis or not? I'm interested in all these 100 persons, right? So my test statistic, can I write this T as a summation of xi? I is equal to 1 to 100. Yes or no? Why I'm writing like this? If you read the question carefully, so there is two things only, right? Whether it's relief or not. Yes or no? For a single person. Are you getting my point? For a single person, there is only two possibilities. They got relief or not. They got relief or not. Yes or no? Are you getting?
Yes.
Okay. So what is the distribution of xi here? Summation of xi is a binomial.
Yes, sir.
Right? What is the mean? NP. I mean, what are the parameter?
NP.
100 comma P.
0.4.
Forget about 0.4. I'm just taking P. So far, so good. Any doubt?
No,
The
sir.
role of test statistic here? Yes or no? Since
Yes, sir. Clear.
clear, right? Since sample size is large, which is 100, so by the central limit theorem, can I say T is approximately normal distribution with mean what will the mean now?
It becomes n times mu.
That is 100 into p, comma, what will the variance? N into p into 1 minus p. Is this clear?
Yes, sir.
Okay. Now, in the question, what they are saying, they are going to reject H naught if this T is greater than
C.
Greater than C, greater than 50. If you see, they are saying if more than 50 of them are found to be relieved, we reject the null hypothesis. So this T represents the summation of all xi, those 100 people, whether they are relieved or not. Is this clear? So why this important? This part is important because only then I can convert into standard normal form. Okay, is this clear? Because of the sample size. Yes, no, anything. If you are not getting, let me know. If you silence is there, I will.
So it's clear.
Clear, right? So while a key difference you can see from the previous question. In the previous question, original distribution was normal and the sample size was 9 itself. Since it was normal, I can convert into standard normal form, right? Sample size is small itself. But if you see here, original distribution is not normal. This is something binomial, right? But sample size is large. I can convert into normal distribution. Yes or no?
Yes, sir.
Are you getting the difference, right?
Yes.
Okay,
Yes, sir. I'm getting.
Yeah, in the question we have to find the probability of type 1 error. So should I solve it? If I will solve it, you can solve for type 2 error. Is this okay? So we have to calculate type. What is the probability of type 1 error? That is, I'm talking about alpha, right? So this will be probability of reject H naught when H naught is true. Now when you will reject your H naught? If T is greater than 50. Given that what is the H naught? P is equal to 0.4. So here you can say sometimes alpha was given to you, you have to calculate C. Here C is given to us and we have to calculate alpha. Okay, any doubt? So what is the next step? What is the distribution of T here? It's a normal 100 P, 100 P into
P
1
minus P.
Basically, it will be normal if I will substitute the value of this case. Okay, let's substitute later. Okay, what? Okay, now you will tell me what should I write? What will be my next step?
We will.
So if
put
P
that
is equal to 0.4, then 100 into 0.4
We
will
have
be.
to subtract mean divide by
Correct. That's what
standard.
I'm doing. So basically, I have to do T minus
T minus
100 times P divide by square root of 100 P into 1 minus P.
Yeah.
Yes.
Greater than 50 minus 100
100 P.
into P divided by square root of 100
100
into P into
P.
1 minus P, given that P is equal to 0.4. So far, so good. Now, this part will be what? Z. Z or G. So can use. So this will be Z greater than, this is 50 minus, I can substitute the value of 0.4. So 100 into 0.4 divide by square root of 100 into 0.4 into 0.6. Yes or no?
Yes.
So this will be basically probability. Can you tell me what is the value of this? Anyone can calculate this part?
It is 10 by
10 by 24, square root of 24, right?
yes, square root of 20.
What is the value? I think 2 point something.
2.04.
2.04. Okay. This is the 2.0. Since this is greater than sign, to substitute the value of fz, what I will do? I will do 1 minus probability z less or equal to 2.04. So basically it will be 1 minus fz of 2.04. Yes or no?
Yes.
Okay. So what is the value of fz of 2.04? You can see 0.979. So it will be 1 minus 0.979. So basically answer will be 0.02. So this is alpha. Is this clear?
Yes.
So what is the next you have to calculate? So it says beta, that is probability of type 2 error. So what is this type 2 error? Probability that accept H naught when HA is true, right? So in the question, you cannot take P greater than 0.4, right? I mean, to solve the equation. So in the question, it says P is greater than 0.4, which says the P is equal to 0.6, right? They took 0.6. So what will be the case? When you will accept H naught, first of all? When you will accept H naught?
When T is less than 50.
T is lesser equal to
T less than
T is lesser equal, right? Yes or no?
Yes, sir.
Okay, so you have 2 minutes, 3 minutes, solve this and let me know what is the answer you are getting for type 2. Same steps apply for which I applied for alpha.
So please open that rough page.
No, just solve from here.
Okay.
Sir, can I ask you a out of context thing?
Yes.
Sir, you're Prasan Sharma, right?
Yes, right, whatever.
No. Actually, I just guess. Actually, we did a event on the 14th August, so your voice is kind of similar. That's why.
Okay, are you talking about that talk about the statistics?
Sorry, sir.
Are you talking about the talk, right, which we did on 14th August?
Yes. The
Yeah.
real world.
Yes. Yeah. I was there.
Okay.
Yeah. Okay, so you want any other time limit, or should I proceed?
So 1 minute.
1 minute? Oh, all right. Great.
Sir, I have a question.
Mm-hmm.
This alpha value can be like minus also.
Okay. You will give me answer itself. So what is the definition of alpha?
Alpha is
How
like we are
how will you define alpha?
getting the type 1 error.
Sorry?
Which one, sir?
Yeah. What is, how will you define
Which one?
alpha? Alpha.
Yeah, alpha is equal to when we are just a moment. Like type 1 error, which is rejecting HO
Type
when
1 error
HO is true.
or
H naught is true.
only type 1 error?
No, type 2 error also.
No. Is it only the statement of type 1 error, or is there anything extra added to that type 1 error?
It is the probability.
Probability of type 1 error, right? Okay,
Okay, got it.
Type 1 error is this, okay? Alpha is whole thing, probability of type 1 error, right? Now, probability will always be between 0 and 1. Yes or no? Can probability be negative?
No. I got it.
Got that? Okay, all right. Great. Okay, so this is the case. So what was the next situation? Again, same thing. I have to convert in standard normal form. So I will write? T minus 100 into P divided by square root of 100 P into 1 minus P, right? This is already less than or equal to sign. So this will be 50 minus 100 P divided by square root of 100 P into 1 minus P for the given that value P is equal to 0.6. Now this part will be J less or equal to 50 minus 100 into 0.6 divided by square root of 100 into 0.6 into 0.4. Anyone can tell me what is the value calculated?
Minus
So basically minus 10
2.04.
again. Yeah, correct. Same as
Minus
this.
2.04.
Same value.
Minus 2.04. Yeah, I think it's very simple thing.
Yeah, I got the same answer as before actually.
Okay. So one more thing, so FZ of 2.04 is given, right? So not minus 1. So what you can do basically, can you write this as a probability Z greater or equal to 2.04? Yes or no?
Yeah.
Because if you see the symmetricity curve, this is 0, this is minus A, this is A. So probability Z less than minus A will be same as probability Z greater than A. Correct? Yeah. Right? So can I see sometimes this value will be given to you directly, but I'm just trying to explain you some concepts so that you can use it. Now this is greater than terms. Can I write 1 minus probability Z less or equal to 2.04? Right? Yeah. And this will 1 minus FZ of 2.04, and FZ of 2.04 is 0.979. So 1 minus 0.979 will be 0.02 something, right? So this is the beta, which is probability of making type 2. Is this clear?
Yes.
So now you are getting the idea, right? How to start and all.
Yes, sir.
Okay. Okay, so the next question, yes.
What was the answer?
0.02. Okay, all right. So the next question is the proportion of adults living in a small town who are college graduates is estimated to be P is equal to 0.4. Okay. To test this hypothesis against the alternative P is greater than 0.4, you decide to take a sample of adults from the town. So here sample size is unknown. What sample size do you need for a test against the alternative P is equal to 0.6 at a significance level of 5% and power 95%? So you can see two things are given to you, right? It's given that significance level and power, right? And you have to calculate the value of n. Usually n is given to us and we have to calculate the other thing, either alpha or a 1 minus beta or beta. Yes or no? Here I mean approach should be same, just change in the situation. So what we will do, we will take alpha, we will take 1 minus beta, which is power of the test, and we will try to calculate the value of n. Okay, would you like to do, or should I start? First of all, what is the, okay, let me do. No. So what is the h naught? P is equal to 0.4, and alternative is P is greater than 0.4. Yes or no? Right, this is given to us.
Yes.
Okay. Okay, so what is the alpha? Alpha is given to us 5%, and 1 minus beta is 95%. Basically, we have to use this one and this information to calculate the value of n. Okay. So one more thing, can you tell me from here, as usual, if this is the, we are talking about in terms of proportion, right? So what will be the x bar? Okay, suppose x1, x2, so on. This all are xn from IID x. Okay, and we are talking about proportion only. So what will the distribution of x bar? Okay, before going to that, what will the what is the meaning of this proportion x? Okay, proportion means, are you getting number of success? Basically, I'm trying to say.
Sir, ratio.
Yes or no? Yeah, right, of kind of ratio. Yeah, success ratio basically. Okay. Basically, if you see in the question, so they are trying to find the proportion of veterans who are living in a small town. Okay, who are college graduates is p equal to 0.4. So can I say, tell me, can I say x bar is normal? Okay, with the proportion p and mean p and variance p into 1 minus p divided by n. Basically, it's a Bernoulli concept. I mean, each xi either in they will be in small town with college graduates or not, right? Only two possibilities. Yes or no? So basically, your summation of xi will be binomial this np comma np into 1 minus p. Correct? Basically, this p is defined as a this total and divided by number of people who basically favorable cases. Okay, so what will be the x bar? X bar will be x1 plus x2 plus so on xn divided by n. So by using this information, it will be p plus p plus p plus p equal to np divided by n. N will get cancelled out. It will be p only. Yes or no?
Yes, sir.
Are you getting this part? Yes or no? See, first of all, each xi is Bernoulli or not?
Yes, sir.
Each xi is Bernoulli, right? If each xi is Bernoulli, then what is the mean of Bernoulli? Expectation of each xi is p. What is the variance of each xi? P into 1 minus p, right?
Yes, for Bernoulli.
For Bernoulli. So in case of normal distribution, if it follow normal distribution, you know what, if x bar follows normal with mean mu, so mu is p, variance sigma square by n. So it will be p into 1 minus p divided by n.
Yes.
That's what I
sample variance.
Sample variance. I mean, this not sample variance, population variance divided by n. Okay. Now, is this funda clear now? How I wrote this x bar normal p comma 1 minus p, p comma 1 minus p comma p into 1 minus p divided by n. Basically, mean comma variance. Okay. So what will be your test? Basically, test is you will reject your h naught when? Tell me. If
P is equal to 0.6.
No, x bar is greater
than c.
That is the test, right? P is equal to 0.6 you will use to calculate the 1 minus beta power of the test. Okay. Okay, by using this part, this hypothesis alternative, is this test is clear? Okay. Yes, no?
Yes, sir.
Yes, sir.
You are getting part, right? Now, so alpha is given to as a 5%, 1 minus beta is 95%. So what will be the alpha? Alpha is probability
0.05.
Yeah, so we have to follow this step. Reject h naught when h naught is true. So what is the reject when you will reject? X bar is greater than some c, given that p is equal to 0.4, right? So this is 0.05 equal to probability that what is the x bar is greater than c. So so it will be x bar minus p, right? This p divided by square root of p into 1 minus p divided by n, right? Greater than c minus p divided by square root of p into 1 minus p divided by n for p is equal to 0.4, right? Now this is going to be g. So this will be z or g greater than c minus, I will substitute the value of p, which is 0.4, and divide by 0.4 into 0.6. So this is 0.24 divided by n. Yes or no? So basically it will be 0.05 equal to, can I write this as a 1 minus probability z less or equal to c minus 0.4 divided by square root of 0.24 divided by n? Would you agree with me? Yes or no? This greater than sign, can I convert it less than sign? Now from here, can I write probability z less or equal to c minus 0.4 divided by square root of 0.24 divided by n equal to 1 minus 0.05, which is same as 0.95? Yes or no? So from here, I can write fz of c minus 0.4 divided by square root of 0.24 divided by n equal to 0.95. So from here, basically it will be c minus 0.4 divided by square root of 0.24 divided by n equal to fz inverse of 0.95. So value of this will be given to you. So what will be value of c here? C equal to let me write one more step. So it will be c minus 0.4 equal to multiplication of 0.24, square root of 0.24 divided by n, fz inverse of 0.95, and then this will be c is equal to 0.4 plus square root of 0.24 divided by n, fz inverse of 0.95. So this you can keep make a note of it, basically make it as equation star. So what okay, so we got one c from here and another c we will calculate from the 1 minus beta. See, at the end we have to calculate the value of n, right? To calculate that value of n we need two equations. So from the given two informations we have to solve this. So first of all, then similarly, okay, is this step clear for alpha we got here in
Sir,
general?
please scroll down. Little more. Yeah, clear.
Clear, right? Now, what is the 1 minus beta? Power of the test is given to us. So, probability of reject H naught when H is true. So, when we are rejecting H naught, X bar is greater than C. And what when H is true? So, if you see, we have to find, we can use this P is equal to 0.6 for the 95% power. So, P will be 0.6. Okay. Now, okay, so I'm skipping this step. So I can write directly z greater than c minus this step, right? So in the place of 0.4, it will be 0.6 only, right? And then in the denominator, it will be 0.6 into 0.4, again 0.24 divided by n. Yes or no? So this will be 0.6 divided by square root of 0.24 divided by n. Again, this part I can write as a 1 minus probability z less or equal to c minus 0.6 divided by square root of 0.24 divided by n, and this is 0.95. So from here, what else I can write? Can I write probability z less or equal to c minus 0.6 divided by square root of 0.24 divided by n will be 1 minus 0.95, which is 0.05. What else can I write? What should be my next step? It will be fz of c minus 0.6 and square root of 0.24 divided by n will be 0.05. Yes or no? And then it will be c minus 0.6 divided by square root of 0.24 divided by n equal to fz inverse of 0.05. So now the final things came up. So it will be c is equal to 0.6 plus square root of 0.24 divided by n, fz inverse of 0.05. So one thing you can make a note of it again here. So this is equation number double star. So if you see, we got one c from equation number star and one c from equation number double star. So what we will do, we will equate, since both are left hand side are equal, then we will equate these two. So what will be there? So from equation star and double star, we get 0.4 plus square root of what is 0.24 divided by n, fz inverse of 0.95 equal to this part. 0.6 plus square root of 0.24 divided by n, abject inverse of 0.05. So what you have to do basically, you have to solve these two and you have to substitute the value of these two and these two, and finally you will get the value of n. Okay. So is the idea clear? Yes or no?
Yes, clear.
So you can see, right? So you can see abject inverse 0.95 is there, which is 1.64. Abject inverse of 0.05, which is minus 1.64. So basically, let me write here. I'm not going to solve for this, but just give you idea. So 0.4 plus square root of 0.24 divided by n, and this will be 1.64 equal to 0.6 plus square root of 0.24 divided by n. This is minus 1.64 if I'm not wrong. Yes. Now you have to solve this and you will get some value of n. That will be the answer. So you can see everything is in the information. So what you have to take care of, sometimes acceptance region is given to you, you have to convert in the rejection region and all. So let me see what is the value of n. Sorry. Okay, so value of n is 65. So next question is actually, if you see, the next part was, you have to calculate the critical value at a significance level of 5%. What is the meaning of this question? What you have to calculate?
Value of C.
C, yes. It is asking you to calculate the critical value. So 4 second means basically you can start with alpha, probability that x bar is greater than C, and given that P is equal to 0.4, and n you have to take as a 65, and you will solve it, you will get the value of alpha. Is this clear?
Yes, sir.
Okay, so the last question is this part. I think we can wind up. A survey of 200 randomly selected students from a school revealed that 70% of them participate in extracurricular activities in the school. Can we conclude that 5% at 5% level of significance, that 80% of students participate in the extracurricular activity? So basically, we have to give the decision whether we can accept or not. So first of all, what are the information is given to us? What is the sample size? 200, right? And they revealed that out of 200 randomly this. Okay, first of all, what will be your null hypothesis?
70.
Just think a bit. This 70 is from population. See, hypothesis is always about population parameter, right? 70% is from your 200, which is sample. And what we have to test? We have to test as 80%, right?
Yes.
So my null hypothesis is whether my P is 0.8 or not. Okay. And alternative will be P is, tell me, what should I write? Greater than, less than, what? Yeah, anyone? What should I write?
Is it less than?
Why?
Because they gave only 70% of them participate.
No. Don't go with that. That is the sample. Forget about this. Just ignore this. If I'm saying 80% of A to Z,
Greater than 0.8. It should be.
No. You are not understanding. See, P is equal to 0.8. We have to test this. We do not have any claim about whether it's more than, less than, right? So that means I will assume P is not equal to 0.8. That's all. Okay. It's not say, see this. Okay. Now let's change the situation. Suppose I'm saying in a school, it is given that 80% of the students participate in the extracurricular activities. To test this, they selected a random sample of 200 students and they found 70%. Now, did I mention about less than or greater than? No, right? That is a P is equal to, P is not equal to 0.8. We don't know. So this is two-sided test. Okay. Now, what is the sample size? So again, x1, x2, so on till x200, right? So what about x bar? What will the x bar distribution? It will be normal. Tell me what will the mu?
70% जो था, I think.
No. In general, what should I write? What should I write? First of all, each xi is by Bernoulli 1010, whether they will participate in extracurricular activity or not, right? If each is Bernoulli, so what will the x bar? X bar means
Expectation will be 0.8.
Sir, mu is 160.
this is 200 divided by 200. Let's talk about in general, right? So what should I write here?
Just be mu.
P,
Just
right?
P, yeah.
What is the variance? What is the variance?
P into 1 minus P.
Divided by 200?
Yes.
Right? That's all.
Yes.
Now, when you will reject your test, I will reject, what will my test? I will reject my H0 if, tell me, x bar minus mu, right? Mu, instead of mu, I have P greater than some C, because this is two-sided test, right?
Yes, sir.
Now, we have to start with alpha. Very good. That's the key thing. So, probability that I will reject my H0 if H0 is true. So, this will be probability that absolute difference between x bar minus P is greater than this C, and H0 is P is equal to 0.8. Correct? So, now what else can I write? P is equal to here, what we have to do? Basically, we have to subtract the mean and divide by standard deviation. So, mean is already subtracted. We have to divide by square root of, divide by standard deviation, right? Can
X
I write
bar minus P by P into 1
square
minus
root
P
of
by 200.
square root, right? Not
Into 1 minus P by 200.
Greater than C divided by square root of P into 1 minus P divided by 200, given
C
that
minus P. C
No.
minus P.
No. Already P was subtracted.
Yeah.
To convert into its standard normal, I have to just divide by standard deviation.
Yes, we don't need here.
Yes, it will be probability of G greater than mod of G greater than basically C divided by 0.8 into, it will be 0.8 into 0.2 divided by 200. What is the answer? It will be 0.16 divided by 200, that is 4.0. I think 50 divided by square root 2. Can we cross check? 50 C divided by square root of 2, right? Now, this is something, can I directly write as a, this is Z greater than 50 times C divided by square root of 2, or Z less than minus 50 times of C divided by square root of 2, and then this is Z greater than 50 times C divided by square root of 2 plus probability Z less than minus 50 C divided by square root of 2. And this part again I can, what else can I write? Can I write 1 minus, what else? Can it, probability Z less than
50 C by root 2.
Or else, see, rather than like going
You
like
twice of
can I write? Yeah. Can I write this probability same as Z less than minus 50 C divided by square root of 2? Yes or no? By the symmetricity property.
Yes, sir.
So this will be 2 times. I know most of the people are getting bored now, but anyway, just trying to do stepwise. So this is 0.05 and this will be 0.025 equal to probability Z less than minus 50 C divided by square root of 2. So from here it will be, can I write, let me interchange. So minus 50 C divided by square root of 2 is equal to 0.025. What else can I write? Can I write fz of minus 50 C divided by square root of 2 is equal to 0.025. What will be the next step? It will be minus 50 C divided by square root 2 equal to fz inverse of 0.025. Yes or no?
Yes, sir.
Yes.
So what is this value? Fz inverse of 0.025. Okay, minus 1.96. So from here, minus 50 C divided by square root of 2 will be minus 1.96. Can you solve and let me know what is the value of C? Minus will get cancelled out. So this will be C is equal to 1.96 into square root of 2. Divide by 50. What is the value? Can you calculate it?
0.055.
0.05. Okay. C is the 0.05. What is the X bar? Okay. First of all, what is the X bar minus P? That was the test. So x bar was 0.7. Yes or no? And minus p was 0.8 from the question. 70% is from the sample, right? And p is the 0.8. What is the difference? 0.1.
Yes, sir.
Yes or no? And which is greater than c?
Yeah.
That means what?
We have
I am
to
going to
reject
my H0. That's all. So final decision is reject H0. Okay. So that's all. So we are done. Okay. So I hope you got the idea about this hypothesis testing and all. Okay. Anything else?
No, sir. Thank you.
Oh, okay. All right then. Thank you. Thank you. Bye.
Thank you, sir. Good night.
Good night.